We are now looking at cyclic quadrilaterals. You know, these quadrilaterals which are found in a circle. Remember, we are looking at a circle theorem. So we are told that it is a quadrilateral which has all its vertices on a circumference of a circle. Now, a quadrilateral is a polygon with 4 sides. It is a shape or a polygon with 4 sides. So cyclic quadrilaterals are quadrilaterals which has all its vertices on the circumference of a circle. So if you look at this one is a quadrilateral because it has the 4 sides and all their vertices are at a circumference. So we are told that you are told that opposite angles of a cyclic quadrilateral. We are told that opposite angles of a cyclic quadrilateral add up to 180. Opposite angles which are opposite to each other, when you add them, those two angles, they give you 180. So we have A and C are opposite, and also D and B are opposite. So A plus C, if you add the two, you get 180. And if you add the B and D, BD, you also get 180. A question may come to say A is 17 degrees. Find angle C. You have to say 17 plus C is equal to 180. Then you group like terms and find your answer for angle C by saying 180 minus 17. You have found for A there. Then you get your answer once you subtract 17 from 180. In our next, let us have Roman numeral 2, where we are going to look at the exterior and opposite interior angles of a cyclic quadrilateral. Okay. Another one is what we call exterior and opposite interior angles of cyclic quadrilateral. Okay, what we have there is that the exterior angle of a cyclic quadrilateral is equal to the opposite interior angle. We have the exterior angle of a cyclic quadrilateral is equal to the opposite interior angle. What we mean is that when you talk about an exterior, we mean the angle outside. We are talking about a quadrilateral. A quadrilateral is a polygon with 4 sides. So we have some angles which are outside. So this angle is outside. This angle, it is on the same line or on the same straight line to this angle. Let me use another color. It is on the same straight line with this. So this one, it is opposite to this. So this is the reason why they are saying it is equal to the exterior angle of a cyclic quadrilateral is equal to the opposite interior angle. Opposite interior angle of this is angle A. So that is the angle which is equal to angle X. So therefore, angle A is equal to angle X. Angle A is equal to angle X. Let us have one example and see how best it can be answered. So this is the example we have. We are told that angle BAD is 75. Then we have 75 degrees, and we have angle BEC is equal to 25 degrees. The question is calculate, question number A. We calculate A, angle BCD. And the other one, question number B, angle ADC. DC, meaning that angle there. Then another one is CBE. CBE. We find this angle there. So let us now work it out. Let us find the answer. Like I always say, like I said in the previous video to say, we need also the background knowledge on the angles. Sometimes you don't just entirely need to depend on what you have learned, also to need the background knowledge on the angles. The knowledge such as the angles on the straight line, they add up to 180, okay? Angles in a triangle, they give us 180. Such knowledge is very important. So let's answer this one. We are starting with the question number A, where we are finding angle BCD. Angle BCD, it is equal to, actually it is equal to 180 minus BAD. Why? Or if you don't mind, you can say, if I add angle BCD, I add it with this angle, I'll get 180. So therefore, to find this angle, you are going to say 180 minus this. The reason behind is that we looked at this one in our previous, in the same video. We have looked at this one where we are saying opposite angles in a cyclic quadrilateral, they add up to 180, where we had the A plus C is equals to 180, B plus D is equal to 180. So we are going to say therefore, okay, instead of therefore, before we reach to therefore, we are going to say 180 less 75 degrees. So we are going to have BCD is equal to, what is 180 minus 75? You get a 1 there. There you will made with a 7. There it will be 5. Then there it will get to have 0. It will be 105. So 105 is the angle we are getting there. Now, for the sake of progress, you can still indicate that one as your 105, so that it will help you to find even other angles. Now, the other question, which is question number B, is that we find the angle ADC. We find the angle ADC. How do we find the angle ADC? How do we find the angle ADC? This angle. Remember, from what we have just from learning is that this angle there, it is the same as this angle. That angle there is the same as this angle. So this angle here, it is supposed to be the same as that. Now, if we don't know this one, so it will be difficult to know that one. So let us first know this angle. How are we going to know that angle? We are going to know that angle by, first of all, finding angle B. I will say BCE, which is equal to 180 minus 105. I don't know if you are able to see that one. Yeah, it's clear. To find BCE, this angle here, we have to say 180 minus 105. Why doing that? Because it is a straight line. It is a straight line. So this one will be equal to, it will be equal to now 75 degrees. In other way around, this is the exterior opposite to this. It is the same as the exterior opposite to that. So it will be 75. Now that it is 75, we have known that it's 75. We are going to take advantage of this angle where we have C, we have B, we have E. There we have 25. There we have 75. There we don't know. So to find that angle there, which is this angle here, it will be 180 minus 75 and also minus 25. Because this is angle in a triangle. I've gotten this one as my triangle. So it will be 180 minus 75 minus 25. Let me just write it. 180 minus 100. Because 75 and 25, they add up to 100. So 180 minus 100, the answer is 80. So this means that angle there, this angle here is 80 degrees. Now, coming to the question, ADE or ADC, it is the same as CBE. It is the same as CBE. Wow. It's almost I'm answering also question number C. Anyway, let's move on. Since we have known ACB, since we have known CBE, C or CBE, since it has been known as 80, it will mean that even the ADC is also 80. It will mean that even the ADC is also 80. The reason is exterior and opposite interior angles are equal. Exterior and also opposite interior angles are equal. So that is what we are going to have. Now, therefore, on the question number C, where we have CBE, it is equal to ADC. 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 This one, it is equal to this exterior angle. So we are going to say CBE, it is equal to, because this one is known, even that one, it is the same. So this is the way we handle such kind of questions. How did we find question number A? Because of opposite interior angles. How did we find question number B and C? Because of opposite exterior angles. Because of interior and also opposite interior, exterior and also opposite interior angles. So this marks the end to this tutorial. We are going to continue by looking at tangents in our next video. Thank you so much.